Hi, today we're going to take a look at the quick 861DW hot air reflow / repair station, a hot air device designed for rework and repair of PCBs, or basically modern surface mount soldering if you've got solder paste and stuff like that as well. And thank you very much Lewis Rossmann from the Rossmann Repair Group and fellow YouTuber. I'll link him in at the end of this video. He's actually done a review of this one as well, and he actually provided this for me. I was going to buy one myself because I needed a better repair station, and he recommended this, but he sent me one. He had already sent me one into the mailbag, so thank you very much, Lewis. And he actually recommends, off the bat, he actually recommends this one as over and above the Heiko that he used to use and the Weller ones as well. And he recommends this one as basically at almost any price point. So given that he's a repair professional, he does repairs every day, and he's a no bullshit guy, he knows what he's talking about here. But he wanted me to take a look at as well, because it apparently it made the lights in his shop flicker. So we might actually take it apart. There might be some, RFI interference, line conducted mode interference. I won't go to town researching that, but we'll do a teardown, which Lewis hasn't done, to check out the build quality. But as far as the performance goes, he swears by this now. Now, I have looked at a repair at a hot air station before, which is the cheap ass Atten 858D Plus here. Now, the quick, by the way, is about $300 US, as you see it here. The Atten 858D is like sub $70 delivered. So it's, it's really cheap. Everyone should have. If you're into electronics, you should at least have something of this level, that just a hot air gun that allows you to just rework and remove, basic small surface mount parts and stuff like that. And it's okay. I've been using it since I did the review. It's my main, because I don't do repairs of motherboards or other items with big ground planes and huge components that sink all the heat and everything. So this has been it's been adequate for the task. It has struggled in a lot of times. It just doesn't have the heat, doesn't have the airflow, doesn't have the capacity to remove, large items and stuff like that. So it struggles, and it's been a bit dicky. It's supposed to go into sleep mode. When you put it on here, there's a magnet or whatever in here, but I found that dicky. It doesn't always work. It's positional attachments. Yeah, I need something with more capacity. So I was going to get one of these for the lab, but let's check it out, see if it's any good. But we're basically talking chalk and cheese here. This is a really like a high-end sort of, big airflow capacity unit, whereas this is like, hobbyist grade, just for, very small boards and simple, small, low thermal mass components and stuff like that. Now, first of all, it does actually come with 3 different size nozzles. Excellent. There was also 3 extra larger sized nozzles, and angled like that, which could be really ergonomically handy, and also for getting, if you've got other components in the way or something like that. But I'm not sure if it comes with that. They were in a separate bag, so Lewis may have included those. I don't think they actually comes with it, but you can obviously buy them. So let's actually try and put one of these on. Obviously, you're not going to do this when it's hot, but I really do like the way that goes in. It feels like nicely, everything's nicely machined, and it is a nice fit, and it clips right in. That feels really professional. That's a Bobby Dazzler. Then we've got the stand itself, which actually feels, there's a bit of weight in that. Feels really solid. It's got some rubber on the bottom so it doesn't slide around on your bench, and I really like the design of this, how it has this sort of outer ring thing, plastic ring, which then just sits in there like that. That is really quite nice. It's kind of hard to sort of miss that. You can just go whack it in like that. So not only does that sit in there very nicely, I like it, but it also provides a little removal plate. Oh, that didn't work. I've got the tripods in the way. There we go. Bob's your uncle. And that's not going to fall out. You don't really have to worry about that. I mean, if you pull on it, it's going over, of course. You're moving around the bench, swinging on your chair, and your leg catches it, it's going over. But maybe I would have preferred something flat perhaps, you know, because then it's just lower profile on the bench, perhaps. Coming over like that just creates, you know, it really is quite a substantial size up here. It's just easy to get caught on there if you're, you know, moving around the lab doing stuff, but I do like it. And the handle actually, the quality of the plastic on the handle actually feels quite reasonable. Oh, that unscrews. Anyway, I like the rubber hose on here. It feels really good. I might see if that's burn proof. I might get the iron to that. But that, you know, it feels, the strain relief on that feels really quite professional. Let's try and open this puppy up. But that comes off. I like how it's cable tied inside here, and not one but two cable ties. That's a nice attention to detail. They've got some heat shrink, or not heat shrink, but insulation tubing down in there, which looks like it has another plastic sort of guide in there or something like that. It looks like the contacts in there are crimped down in there. It all looks very, very well designed. I'm quite impressed by that. Of course, it's going to have more than the heater element. There's going to be a sensor in here which detects when it's on the stand. It's obviously detecting that there's metal that goes over the top of this part here. So it's got to detect that somehow. I'm not exactly sure how. Probably some sort of Hall effect metal type thing. Anyway, everything looks nicely heat shrunk or, you know, properly crimped down inside there. So I deem that to be quite a professional construction. No worries whatsoever. I think to get it apart any further, I might have to take out these rivets here. So I don't really want to do that. So we'll just leave it at that. Heating element, you can see, is that the ceramic former down in there for the heating element? I don't know. I'm not going to take it all apart, but oh, is there like a big copper heat pipes around there? I don't know. Kind of looks badass. Now, as for the station itself, looks really quite high quality. Got the metal case around the outside. I like the user interface, really easy. Temperature just up and down. Have to have a look at the display when we power it up. And the airflow up and down, that's exactly what you want. And it looks like 3 different presets, because when you're doing, especially production soldering or production repair, when you've got like the same like a common component that that's always failing and you're always repairing, I'm sure Lewis can tell you all about this, then you would know, you know, you might have like 3 presets or whatever, and you go, oh, okay, I'm removing this, you know, memory chip or whatever. Bam, press that, and it's set up with just the right temperature and airflow you need to take off that particular chip with that particular thermal mass. So that's quite good, and power on off, and Bob's your uncle. On the back, very basic, we've got our air intake there because it's got to suck the air in from somewhere. We do have a grounding point, and I do believe it does come with a grounding strap which you can put over to your ESD mat or whatever, so that'd be mains earth. It's fused, and it's, of course, made in China somewhere. It doesn't say it, though. It's got the dodgy QC pass sticker. Don't like that. Anyway, this is the 240 volt / 220 volt model, and it's 1,000 watt rated. So that's a heck of a lot of BTUs, or choose your unit. You know what we say here on the EEVblog, don't turn it on, take it apart. Right, let's have a squiz inside this thing. Oh, there you go. We're in like Flynn. Geez, that's much smaller than I expected for the motor. We've got an inlet port here, which just, you know, sucks the air from around there, which is fine. Just sucks the air from around everything else, which helps with the heat dissipation inside. Geez, oh, okay. No, I thought they were just, they're angled. The PCB's angled. That just looked weird. I thought that they were like, the board was hanging off or something. No, but the board's actually angled in there. Let's take a look down here. Oh, look at that. That's interesting. We've got our grommet on the back, a very traditional type grommet, and then there's a crimped lug around that. That's all right, but look, they've got the sleeve in here, so that doesn't, you know, that's a nice touch. So the mains wiring going to the switch at the front, it doesn't, you know, get cut by the sharp burrs or anything on any, well, not that there are any, but just the potential there for that to happen. Everything's heat shrunk. I would have preferred another full heat shrink over there, because technically I could get in there and touch. Maybe there's a little bit of exposed, but you know, look, it's nice and neat and tidy. I like it. The earth Yep, down there. It looks like they've got some Loctite down on that. Very nice. Looks like they might have one of those penetrating washers down there. And then we've got our earth strap bonding resistor there. That's probably a meg, is it? I don't know. I can't see that from here. But that's going up to our earth terminal on the back. And we've got ourselves a nice mains filter on there too. Check that out. So that's very nice. Wow, they've actually really gone to town on that. That looks like it's got all the requisite approvals and everything else. It's a DL10T1. I'll pull up the data sheet for that. But basically that answers our question about, well, the question I had is with Lewis and his flickering lights in his lab when this thing was turned on, presumably just the pump, you know, turning on, was that it caused the lights to flicker. And I suspected that was most likely conducted line interference, which means that the motor generates interference, which then goes back on the line and through the mains cord out the back. But a big EMI filter like that, that should do the business. That should have a massive common mode choke in it. So I'd probably rule out conducted line interference. But anyway, it's all very neat and tidy. I love it's all professionally heat shrunk and done. It's very nice. I guess you could say that motor looks a bit wimpy. I like how they've cable tied that around. They've done everything properly because, you know, there's going to be a lot of vibration. Oh, that's on a vibration mount too. Nice, nice. Yep, there it is. Rubber grommets. Excellent. So it doesn't generate too much noise. I haven't turned it on yet, so I don't know how much noise it generates. But yeah, it's all very professionally built. Another earth strap down there. Once again, they got the Loctite all over the place. Cable ties everywhere. Geez, this thing's somebody had fun.
Holy Toledo! Somebody had fun.
Wow, doesn't that motor drive board look spunky? I like it. There'd be the D-Pack MOSFET drivers there. Very nice. I'm not sure what the main controller is there. Can't read that on the screen. But yeah, that looks very well designed and manufactured. No worries. And you'll notice that the tubing going off, of course, we've got the air. So what we've got there is there we go. That's our heater element. We'll follow the money on that one in a minute. And this would be your temperature sensor, and also for the temperature regulation, of course, of the element, and also the detection for the stand. When you put the probe on the stand, it goes into sleep mode. And we've got ourselves mains earth there. So if I measure that, that will no doubt be mains earth connected. So that provides mains earth shielding for the switching element right up the top. Of course, I don't see any common mode chokes, or like any sort of chokes or filters on the switch-in cable. So maybe it is radiated interference that Lewis is seeing as being picked up by his lab lights. There's the main front panel board, which looks very nice as well. We've got a processor. I might be able to get down there and have a look at what one that is for those playing along at home. Here's our mains input here, of course, and that's our switching element out. Look, very nicely crimped and then into screw terminals, and they've all got the insulating sleeves on them. I really like this. This is very much better constructed than I would have expected for the price. Although, you know, there's not a huge amount in these things, so, you know, $300 US worth, you'd want it to be at least reasonably constructed, and it's certainly that and more, I think. And the capacitors in these are Jamicons. It looks like they've used them all over there, including the motor drive board. And Jamicon are one of Taiwan's biggest and oldest electrolytic capacitor manufacturers. I rarely see Jamicon caps, but, you know, they're reasonable. They're going to be decent, I think. I don't actually know what series it is, but meh, it's certainly not the Shenzhen market One Hung Lo brand. And there's our Triac, and it looks like genuine ST, a BTA 40 series 40 amp Triac. No worries, that's going to do the business. All the, oh geez, that soldering's a bit, how you doing? Well, actually, well, the soldering's probably okay for the lead free, but all the flux residue and stuff, that's the only negative I've found so far. Anyway, optocoupling, the layout's actually looks quite reasonable, and there's our snubber cap across there, and somebody's really gone to town on the thermal compound there, but never have too much thermal compound. Actually, you can, because it gets to a point where if you have too much, it actually decreases, well, it increases the thermal resistance. So, you know, it's got to be just right. And the micro down in there, not sure if you can see that, but that's an ATmega 16A. So, could probably be hacked, you know, put your own hacked firmware on it if you really needed to. I don't see why, but you know, it's just a control loop basically, and a display thing, unless it had some annoying interface quirk, which I don't think it's got. It's just got up down buttons and temp up down and flow up down and memory. So, you know, don't know why you want to improve on that. Loctite on all the connectors in here. So there you have it for the teardown. I'm very impressed by that. It's hard to fault that thing at all. You definitely get your money's worth. So definite thumbs up on here. I've never done a teardown of a higher end, you know, Heiko or Pace or anything like that. But, you know, they might maybe be a bit better built in terms of like a more solid in terms of, you know, chassis. This is just your, well, it's not even your, well, it's just folded metal at the back and just your plastic cover at the front. But like that's pretty much as good as it gets, especially for this price point. They just know what they're doing. There's attention to detail on almost every aspect of this thing. So I'm thoroughly impressed. Thumbs up. All right, let's power this baby on. Have a look. Beep. That's it. Doesn't read anything, presumably, because it's on the stand. So let's, oh no, there we go. We can adjust it. What's the minimum? The 100? Yeah, no worries for doing heat shrink and stuff like that. What's the maximum? The velocity control is constant. It's all right. It's not the most tuned thing I've seen. And 500 Celsius, no worries. None of this Fahrenheit rubbish. Maybe you can change it. Can I see an extra symbol on there? Not really. Oh, it vanishes. Okay, so that's the current, obviously the current thing. And I don't know what the 1 up to 120. Okay, that's a lot of resolution on your airflow rate. That's huge resolution. So no worries. I don't know what that is in, like, you know, liters per minute or whatever volume thing you want to use. But let's give it a go. Okay, first thing we'll do is set it to 100 and we'll get a thermocouple and actually measure that. Going to check the rotation on the stand. Doesn't seem to matter. Wow, that's good. Yeah, I'm so used to the Dicky one on the, just not working on the Atten one. They've implemented that very well. So it's like, as soon as I, yeah, take that out. So it's got to be some sort of magnetic, oh, yeah, there we go, it goes down. And then boom. Whee! Nice. All right. Oh yeah. Oh yeah. Yeah, it's getting hot. It's warming up. Tell you what, it's pretty silent too. It's hard to get audio on the. Oh yeah. It's very. Maybe you might use that for. I don't know. I don't know what you'd use one for. Maybe you wouldn't even use that for heat shrink. Jeez. But even at the maximum airflow rate, that is remarkably silent. Wow, very impressed. So I'll just compare both of these on maximum volume. So I do have manual mic level, so let me take it off. So this is the Atten. And this is the Quick. Actually, come to think of it, maybe the Quick is a little bit, might technically be a bit louder, but it's just got a nicer sound to it. This one's just like rough as guts, and just sounds like it's struggling, and it's just, you know, it sounds like a hairdryer or something on low volume. But this one just sounds like a bit of industrial kit. I mean, it is like a higher frequency sound to it. I don't know. It just instills more confidence. Okay, let's measure the temperature, shall we? Get our K-type thermocouple, maximum airflow. Just stick it up the clacker. And, oh geez, that's not bad. Tell you what, you know, like you expect like a 10% tolerance or something would be fine. That's all right. It's settling down a bit. I don't know. You tell me. I don't think so. I don't expect these things to be terribly accurate. Okay, how about at half the airflow rate? 8%, 9%, 10% over. Okay, let's have a look at the Quick at 300 degrees. See if it overshoots. I've got it on 60. Whoa, geez. It said it got up there pretty quick. Now, the thing about the Quick is that it doesn't display the actual temperature, whereas the Atten seems to do that. It's getting up there, but it's definitely not going to overshoot, so you don't have to worry about this thing causing you any problems with temperature overshoot by the looks of it. That's good. So it's starting to melt. Starting to melt. I think that could be above our K-type. What does our K-type thermocouple go to? No, see, it seems to actually have a temperature reading there when it's going down, but not on the way up. So that's a bit interesting. Maybe I have to RTFM. Yep, there it is, real temp. Not sure what that like indicates, like a buzzer or something. So the real temp is, take it off, and there you go. Whoop. No, there you go. Well, it's saying it's 3. That is, like, it's almost, yeah, a real temp. That's apparently what the sensor's reading, but that's just too stable for my liking. So I'm not sure what the deal is with that. But certainly, if I stick it back on there, it's still showing real temp, and it goes down. It can't regulate that well. And of course, my K-type thermocouple is probably not doing the best of business in measuring the temperature. So just use that as an indicator. Oops, yeah, I thought my probe could go to like 300, but turns out it's only 260 it's rated for. So let's try the Atten on the other hand. Set to 250. And oh yeah, she's going over. Uh-oh, that's not good for my probe. Yeah, yeah, look, I mean, you can see, oh, sorry, you can see the indication. It went up to like 320 something on the indicator. That's terrible. The Quick's got pretty darn good regulation compared to the Atten. It's brilliant, actually. All right, so I'm going to actually try and remove a quad flat pack like this. I don't know, it's just because I've got it lying around. So there's probably, you know, some thermal mass in there. There's internal layers. This would be at least a 4-layer board. So, you know, actually, given the lack of traces on the outside, I think this is like a 6-layer board. So yeah, let's just try and suck out one of those. I'm going to set it to maximum airflow rate and 400 degrees Celsius, just because I don't know. I could set it to maximum, but yeah, let's just try 400 and see what happens. I'm going to have the widest nozzle I've got. I've actually plugged it onto the main board just to hold it in place. Let's give it a whirl. Oh, hang on. Oh yeah, that came off much quicker than I thought. Wow, hang on. Yeah, I actually made the mistake of thinking that it would take longer, but it didn't. Wow, well, considering that was my very first attempt at using this, and that was a large QFP part, wow, that just came off real quick. I should have, like, even my tweezers weren't wide enough, kind of had to spread them. So that was a bit of a goof, but wow, that came off very nicely and very quick. I forgot to time it, but geez, that was probably not more than 15-20 seconds before it started to do the business. Tell you what, this is where you really start to appreciate the pull-off nature of the Quick one, because this Atten one, it's got this stupid screw-on type thing with a notch in it. Don't like it. Don't like it at all. Okay, let's try the Atten. Once again, full airflow at 400 Celsius. Got a bigger tip. Sorry about that. I thought bigger would be better than the other little tiny one I had on there. But geez, that ain't. I mean, I could see the solder go. I don't know if I haven't played this video back, but I could see the solder go before with the Quick, and it just, geez, come on. And this thing's supposed to have overshoot too. It's just not getting the volume. Oh no, there we go, got it, got it. All right, let's try this TMS 320 BGA. I've just got a random teardown board. Can't remember what this comes from. And it's, you know, it's probably like a 6 or 8 layer, well, it's probably a 6-layer board or something like that. So let's give it a whirl. Once again, 400 at the maximum airflow rate. I had success with that before. So let's give it a go. I mean, we could, you know, crank it right up to 500 or whatever, but that's not. There we go, got it. Okay, let's try, say, a D-pack on a VGA card if you wanted to, or graphics card, you know, whatever. Let's give that a whirl, because it's got a, it's connected through to a decent sized ground plane, no doubt. Come on. There we go, saw it melt, I think. Yep, beautiful. And I don't think we touched anything else around there. The sticker's a bit charred. It's a bit worse for wear, but nothing else. That just came off a dream. No worries. All right, let's do a comparison with the Atten. Once again at 400 max airflow. I mean, you know, you could crank it up to 500 if you really want to. Some people have their own preferred techniques to keep it lower for longer or keep it higher for shorter time period, but anyway. Wow. Really need a fume extractor. Blah. Tell I don't do this for business. Come on. You can do it. You can do it. Come on. Wow. Come on. Can't see the, oh, there we go. The solder just went. Boom. So as you can see, the Atten, I think, took a bit longer, seemed to struggle a bit more. I would, you know, I get a better warm and fuzzy with the quick, and I think if you actually put a timer next to that, it is quicker, as you'd expect, no doubt, because there's just, you know, we're talking about a $300 station compared to like a $70 station. So, you know, it's just, but if we had really bigger thermal mass parts, the quick is going to do the business better. Another power package, let's go. Shouldn't have any problems. This is on a fairly beefy multi-layer board. So, come on, you can do it. You can do it. Wait for the solder to melt. You can usually visually see it. Usually see it go. Come on. There we go. There she goes. No worries. I found one annoying thing. You can't adjust the temperature while it's on the stand and cooling down. That's really annoying. You can't adjust anything. Damn it. Okay, let's see if we can store this. If we hold down, I presume, I haven't read the manual, just hold down channel 1. Yep, channel 1, there you go. So let's say we wanted 320 and, I don't know, 47 on channel 2. Geez, that's much quieter. There we go. Store it in channel 2, and then just, whoop, jump over to channel 1 or channel 2. Nice. Okay, I've let it cool down. I'm going to try the adjacent part to it next to there, but I'm going to try it at 300 instead of 400, just to see what sort of capacity it's got at the lower temperature, because you may want to set a, you know, if you don't like, or or there's a technical reason why you can't go to the higher temperature, and generally you want to desolder and solder at the lowest temperature you possibly can, especially when you're leaving the air on something for a while like this. Let's see if we can do it at 300. So it's the exact same part. Let's give it a go. Oh, has it? Yep, got it. Hang on, it's very close. Yep, no problems, 300. So I'm actually very impressed like that, to get that off with a 300 max air temp, and we've seen that it doesn't seem to overshoot on temperature. So, and by the time it gets into the chip, it's probably not going to be 300, you know, because there's loss in the, what, centimetre, half a centimetre we had towards, like, getting to that chip. Going through the air, it's going to spread out and cool down by the time it gets there. So that did a really good job at 300 degrees C. I'm impressed by that. Okay, so I'm going to try the Atten one now at, once again, 300 degrees C, max airflow. It's not an identical part, but pretty darn close to it. So, you know, maybe we'll give it a bit more slack. But let's see if this Atten can do 300 Celsius. And this Atten's known to overshoot, of course. But let's see if it's got the heat flow possible at 300 degrees C, because it's all a matter of airflow too. You can't just always, you don't want to always set your airflow to maximum. And so we'll give this a go. Come on. So it's a delicate trade-off. I mean, you know, experience plays a huge part in this. This is how someone like Louis Rossmann makes it look real easy in his repair videos, because he does it every day, and he's done it the same part hundreds of times. And, you know, whereas someone like me who does not do repair almost at all, basically, compared to someone who does it every day, makes a heck of a difference. You get a much better feel for the airflow and a good airflow and temperature you can use to do that. Oh yeah, there we go. Atten still does it. Actually, based upon the parts I've done now, the Atten's actually doing quite a reasonable job. It is definitely not as good as the Quick. The Quicker does it quicker. Go figure. Because it seems to have a greater heat volume, as you'd expect. But the Atten's kind of holding up. But hey, you know, this could make the difference. This can do it quicker and maybe at a potentially lower temperature as well. That can make a difference between lifting tracks, damaging nearby parts, all sorts of stuff. And, you know, it could cost you a lot of money in scrapping a board or something compared to the price difference between these two. If you can pony up for the money for the Quick, I'd definitely do it. Just for kicks, I'm going to ramp it right up to 500. I'm going to use this bigger right angle attachment. I'm going after this bad boy, this NVIDIA Vanta. Anyone remember that? Oh, hang on, I'll just stop the board sliding around. I should go get a proper holder. We got it. We got it. Oh, no, we lost a couple of pads. Ah, bugger. We lost a couple of balls on there. Don't you hate it when your balls drop? Oh, unbelievable. Look at that. Yeah, well, I didn't, like, this is not my day job. I won't give up my day job for reworking BGA chips. This is not the best. You know, you wouldn't do this. You would use the bigger, like you can get like a desk stand type one, specifically for reworking BGAs and stuff like that. I just wanted to try this for kicks. And yes, it did come off. I probably just didn't leave it long enough before I tried to lift it off. And, you know, obviously the heat, all that underneath was fine, but the ones on the outer ones weren't quite as hot as the other ones. But, you know, considering that's my first attempt at that, using this iron, that worked a treat. Kinda. No, not really. But it came off. Check that out. There we go. That's one sorry looking board. Oops. Now, I was actually going to use my TechBox artificial mains network here, designed for conducted mode emissions, for measuring mains products. Just to like have a little play around with it, just to see Lewis's light problem perhaps. But unfortunately, watch. Boom, it tripped my earth leakage circuit breaker because high leakage current. Oh! So I don't have a non-earth leakage circuit breaker protected outlet here in the lab, I don't think. So much for that. Maybe next time. So there you have it. That's a look at the Quick 861DW. And I think I've got to agree with Lewis. This one is a winner. Winner chicken dinner. I know a lot of people can't afford $300 for a hot air rework station. If you're just doing, you know, occasional stuff like I am, then the Atten's kind of, you know, it's a bit crusty, but it's going to get the job done for your, you know, $70 or whatever. But yeah, this Quick looks really nice, and Lewis has done a bigger motherboard stuff and things like that. He's done some accurate timing. I'll link in the video at the end here, so watch that one. And he recommends this one too. He reckons it's better than the Heiko. It does it, I can't remember the exact model number, FX something or other. So he reckons it wins hands down at any price point. Now, I haven't compared it to other rework stations. It's been so long since I've worked in the business and used other professional rework stations. I'd have to have them to hand here, but this is great. I'm going to love having this in the lab. The Atten is, it's gonski. There's just no, like the Atten can kind of sort of do a lot of jobs, but it's not going to be able to do your bigger, heavy duty jobs that this Quick does. It's got no overshoots. The build quality is excellent. And for $300, it's like a half or a third of the price of the big name ones. So I reckon this puppy's going to sell like hotcakes. So thank you very much, Lewis, for sending this one in. It's going to be a great addition to the lab, and I'll link in Lewis's store down below. I think I'm going to add this one to my store as well. I used to have an Amazon, well, I still do have an Amazon store, so thanks to everyone who buys stuff through there. I get like an affiliate commission. There's a link on my website to do that, but they've like discontinued their stores and stuff, so I've actually got a new kit.com store, which not only links to Amazon, but links to camera places and other online places. And once again, I still get a commission-based thing. It doesn't cost you anything, but I've got some recommended gear on this, and I'm definitely going to add that to my kit.com list thing. And I'm still using the Amazon affiliate program, but it goes through kit.com. So check that down below. I'm going to give that a whirl. Anyway, hope you liked that. If you did, please give it a big thumbs up. As always, discuss down below. Catch you next time.